Okay, good morning and good afternoon or good evening to everyone. Welcome to the Danfoss Turbocor webinar, where we will discuss how to optimize your data center performance using Turbocor oil-free compressors. My name is Eddie Rodriguez, and I'm the marketing manager for Danfoss Turbocor.
Great, thank you, Eddie. So a few practicalities before we get started. By default, your microphone is muted. This is very important to know. So please remember that you can ask your question either in the chat or in the question box. Then be aware that this webinar is recorded, and this is enabling us to have this record posted on YouTube so that everyone can access to it after the Mostra session. And then you can ask a question, as I said, in the chat box, and we just hope you enjoy the show, and we talk later.
Okay, thank you, Laura. Okay, the agenda we'll be following for this webinar is that we'll first start off talking about the benefits of using oil-free compressor technology. Then we'll transition to giving you an overview of the complete line of Turbocor oil-free compressors. And then lastly, we'll conclude by talking about the advantages that Turbocor oil-free compressors offers for optimizing your data center performance. Okay, so with that, we'll go ahead and get started. So probably the first key benefit that you get with oil-free compressors is simply that oil is removed from your chiller system. And by doing that, that really gives you the best possible performance for your chiller system. Oil, it really serves no purpose in your chiller other than to lubricate the bearings. Aside from that, it really degrades performance, especially heat exchanger performance. Now, several independent research studies, specifically ASHRAE Research Project 751 and ASHRAE Research Study 601, did an analysis to conduct a study to determine what the effect of oil was on compressors that were installed in the field. And what they concluded was that over time, the vast majority of chillers were overcharged with oil within the system. And the impact on that was significant in the fact that oil degraded performance by as much as 8% compared to their published performance. Now, another study was conducted by a research university called the Tsinghua University in China. And in this study, the university studied what the performance impact over time was due to the impact of oil on the charge of the system. And what it concluded was that after 5 years of performance, the typical chiller degraded efficiency, or had efficiency that was degraded by as much as 10% after 5 years of operation. As time went on, the degraded performance was more significant. After 10 years, on average, your typical oil chiller had degraded efficiency up to 20% after 10 years of operation. Now contrast that with oil-free compressors, with the fact that oil again is eliminated from the system, and the resulting performance degradation was zero. Oil was not present in the system, therefore there was no change in efficiency over time. Now another perspective to look at, or the issue to be aware of, is that oil-free compressors incur no mechanical wear over time. Now contrast that with your traditional oiled compressors, such as a screw compressor. The issue of mechanical wear can become significant. And the reason is because your typical or your traditional oiled compressor incurs mechanical wear due to the metal-metal contact that you see for major components, such as your rotors, your slide valve, and your bearings. Because those that typical design of that compressor is the way it's set up, is that your rotors come into contact with each other, and as the compressors operate over time, the metal-to-metal contact will degrade the performance of the compressor. Now, in contrast, oil-free compressors incur no metal-to-metal contact over time, and that means there is no mechanical wear that will affect performance over time. A study was conducted in Australia recently, and it examined what the impact of that performance was for oil compressors. And in that study that was conducted in Australia, it found that there was significant bearing wear, capacity slide damage, as well as rotor wear between your male and female rotors that occurred over time. Now, the impact on that mechanical wear effect was significant, and it found that performance degradation was as high as 26% after 15 years of operation. Now, to prove out what we had just said recently in the past couple of slides, in the fact that with oil-free compressors, there's really two significant benefits in terms of performance. Oil is eliminated from the system, so therefore there is no fluid to degrade performance. And then secondly, there is no metal-to-metal contact, which would degrade mechanical operation over time. So what Danfoss Turbocor did recently was we brought 6 compressors that had been operating in the field after 10 plus years of operation. And what we did was we compared the performance of those compressors after 10 plus years of operation versus the performance that was measured when the compressors were shipped brand new. And what we found was consistent with what we have been saying, is that there is little to no performance change over time. The vast majority of compressors that we tested, 4 compressors, saw performance change less than 2%. One compressor had a performance change a little more than 2%. So if you reference HRI standard 540, which determines the acceptable criteria for performance change, our performance change for compressors showed that there was no change over time of operation. Now, the benefits of oil-free compressors extend not just in terms of performance, but also in maintenance. And where maintenance comes into play is that maintenance for specific types of compressors can result in a high degree of expense over time. With your typical traditional oiled chiller, there are several major components that need to be maintained, and if maintenance is not performed, it can result in catastrophic damage of the chiller. Some of the key maintenance items include checking your oil level, changing the oil, replacing an oil filter, as well as inspecting key components to ensure reliable operation. Each of those tasks need to be done quite frequently or on an annual basis. So if you take into consideration the amount of time and the amount of labor that's required to do that, it can be significant, especially if you consider a typical 23-year lifespan of a chiller. So in our analysis, what we have found is that these labor tasks can reach as high as almost $84,000 over the life of the chiller. All these tasks that you see on this chart, because of an oil-free, if you have an oil-free chiller design, they are not required. So this would be a good metric to consider when you look at oil-free compressors. Not only are the performance benefits better with oil-free, but also the lifetime maintenance costs are significant with oil-free compressor technology. Okay, so now we'll transfer to a different subject, and let's talk about the complete line of Danfoss Turbocor oil-free compressors for use in air conditioning and heating. So we offer a complete line of oil-free compressors ranging in capacity from 140 kilowatts all the way up to 1600 kilowatts. Our compressors are suitable for use in operation in a variety of applications, from cooling, heating, process, or heat recovery applications. We also offer compressors that can be utilized in standard lift applications, such as you see on the left. And typically when we refer to standard lift applications, we're referring to applications that are your typical comfort cooling type of applications for use in water-cooled chillers or evaporative cooled applications. We also offer a medium temperature line of compressors, medium lift applications, which are suitable for use in air-cooled chillers, water-cooled chillers with high entering condenser water temperatures, water-to-water heat pumps, and process applications. And then finally, we offer a range of high lift applications, which is the model line that you see on the right. And those are suitable for very high lift applications that are commonly seen in air-cooled chillers in hot ambient climates, such as the Middle East, water-to-water or air-to-water heat pumps, high temperature process applications, high temperature heat recovery applications, and thermal storage applications. So again, we cover a complete line of applications suitable for just about any type of application in air conditioning, heating, or process application. So the next thing to consider is that we also offer a complete line of refrigerants to help in our initiative to reduce the effects of global warming. We offer a complete line of low GWP refrigerants from our TT series that utilize low GWP refrigerant R513A, which offers a GWP of 573, as well as an A1 safety classification for customers or installations that do not allow A2L type of refrigerants. Our TG line of compressors offers two different types of low GWP refrigerants, from R1234ZE, which offers a near zero GWP level, to our latest refrigerant offering called R515B, which is a new refrigerant offering a low GWP of 299, along with an A1 safety classification. Okay, so now let's talk about the reason why we are having this discussion here, and that's to talk about how Turbocor oil-free compressors can optimize the performance of your data center. Okay, first of all, let's talk about some of the unique operating conditions of data centers. Data centers have a fairly unique profile or operating profile in that it's not uncommon that data centers require year-round cooling. And that is simply because it has a high internal load in the building. So it is not uncommon that during the winter time, even though the ambient temperature is very cold, the data center still needs cooling. Now the concern with that is that when you have a very cold ambient space outside, the temperature is cold outside, the chiller that is required to cool the interior space will typically be operating in what we call a low lift condition. In a low lift condition, that refers to simply the difference between your discharge pressure and your evaporator pressure. So if your discharge pressure is fairly low, which is what it would experience at a cold ambient temperature, your lift conditions will be very small. Now, for some applications or some compression technologies, typically like an oiled screw compressor, that can represent some challenges. And the reason is because that type of compressor, an oil compressor, requires a minimum amount of lift to ensure proper oil circulation. So considering that most oil compressors do not have an oil pump, it is going to need a minimum pressure differential to ensure oil circulates throughout the system. Now, because oil-free compressors do not have oil in the system, that type of situation is not a concern for us. So for that very reason, you can see at the bottom of the operating map, we have what we call a low lift operating region. So that enables our compressors to be used even during cold ambient conditions or low lift operating conditions, where we can operate at a low lift operating condition where it's as low as 1.0, which is well beyond the limit of most traditional oiled screw compressors. Okay, the next thing to consider here with regards to oil-free compressors is that recently Turbocor announced a new enhancement to our operating map, which allows for high saturated suction temperature conditions. And what that means is that what we have seen over a trend over recent years is that data centers are becoming more robust. What that means is that the allowable space temperatures which data centers can operate is tending to go higher and higher. This is the result of computer server equipment being designed such that it can withstand higher temperatures. And what that means is to us is that by raising the set point of the space temperature inside the data center, it's going to enable significant cost savings to the end user. Higher temperature settings for the data center means lower operating costs, lower power consumption for the cooling equipment, as well as infrastructure cost savings with the initial cooling costs or cooling setup. So in response to that, what Danfoss Turbocor did is we extended our operating map to allow for this change in design in order to support this initiative of saving on operating costs. So what this means is that our line of TT and TG compressors can now operate at saturated suction temperatures up to 28 Celsius, which will enable to support high temperature operating conditions for data centers. Okay, so the other thing to consider with high saturated suction temperature map extensions is that we are also supporting some of the trends that we are seeing not just with higher temperature settings within the data center, but also a trend that we're now seeing where data centers are now looking to design cooling systems where instead of using a traditional chiller plus airside equipment design, but instead the cooling medium is applied directly to the computer equipment. And one of the benefits of that type of a design is that it can help to eliminate some of your high infrastructure costs associated with providing airside equipment to deliver the cold air to the space, because the cooling medium is applied directly to the equipment. And with a high SST map capability, we can support the higher temperatures that you would typically see by using this direct CPU cooling. The other opportunity with using high saturated suction temperature capability is that for some data center locations, such as in your northern hemisphere locations, it is not uncommon for the cooling to be provided by a free cooling setup. In other words, to use the outside ambient air to cool the data center application. And by doing that, it essentially eliminates the need for mechanical cooling. Now, where Turbocor can come into play here is that our compressor technology wouldn't be necessarily used for air conditioning space or air conditioning the application, because it is not needed, but instead to provide heating. And the way that would work is that the heat load that would be inside the data center, instead of being discharged into the atmosphere, can actually be utilized as a heat sink. So in other words, taking the heat that would normally be emitted inside the data center can then be transferred to a district heating application. So this is a new great opportunity to help minimize the use of fossil fuels for traditional heating applications, but instead using the waste heat from a data center application to provide heating for a district heating application for residential homes or other commercial buildings. Okay. So the last slide that we'll conclude here is that another fantastic feature that Danfoss Turbocor offers for data center applications lies in our response to power blips or loss of power situations that you may see in your area. One of the key issues or concerns with data centers is that they need to operate 24/7 without any interruption or downtime. Any downtime for a data center can be catastrophic. And so for that reason, we offer a fairly unique feature of what we call our fast restart functionality. And what happens is that if there happens to be a blackout or a voltage blip, the capabilities of our compressors allow it to conduct what we call a fast restart. And then what happens is that once power is restored to the application, we can restart our compressor as fast as 30 to 40 seconds, again, once power is restored. And when you compare that response time to a lot of compressors out in the industry that typically require oil for the system or require a much more longer ramp-up time, our response time is typically around 30% faster than comparable technologies in the industry. Okay, so with that, we conclude our presentations. And if anyone has any questions, we are open to fielding anything that you might have.
Yes, thank you, Eddie. It's very interesting options. And I have a few questions here that you might be able to reply right away. Maybe without revealing any secret plan for the roadmap, is there any plan to expand your cooling capacity for Turbocor compressors?
Yeah. Yes, we certainly see the market for oil-free compressors growing. The benefits that we just outlined provide a lot of attractive features and capabilities to customers. So yes, we are obviously looking to expand our capacity. We're looking to expand our ranges to more applications such as modular types of applications, which would extend the benefits of oil-free compressors to a wider range of applications.
Great, thank you. Another one is maybe we missed that point in the presentation, but what is your maximum operating saturating suction saturating temperature for
Yes.
this with this Turbocor.
Yes, yes, that's a good point. The key feature that we're trying to emphasize here that is a recent enhancement is the addition of the high SST capability to our TT and TG line of compressors. And for those compressors, we can reach a maximum of 28 C saturated suction temperature. Now, there are going to be some compressors depending on the operating condition that can get maybe a little bit higher, because it really all depends. It is a function of your operating conditions, your load conditions, etc. But in general, you should be able to see 28 degrees Celsius capability.
Great. And thank you for the conversion from the US.
No problem.
I have another one, which is because it's a fairly new solution, Eddie. Where can we find this solution? Is that something you would like people to turn directly to you for asking more questions, or how do you see this?
Yes, please feel free to contact Danfoss Turbocor if you have any questions. But yes, we also ask that you contact your local OEM provider. This capability is obviously open to our OEM partners. So please refer to them and ask them for this capability for your next data center project, and ask questions. And again, we are also just as a reminder, we are also available for any questions that you may have as well.
Thank you. And I think that's it for the questions now. Yes, it's a good remind. We have Giuseppe Piol and Davide Maestro who are present at the booth. So if you need any contact, you can reach out to them directly. If you are looking for more information, of course, you just go on danfoss.com, turbocor.danfoss.com, and you will find the related information to these compressors. And last point, because it's important for those who are interested, there was a meeting this morning, a webinar held by Stefan Pietrek about all the Danfoss solution for data center. And there will be also more webinars, one about the latest solution for scald chillers this afternoon, tomorrow morning. There will be another one in English as well for the close control, latest solution for close controls, which is also part of the data center story. And Giuseppe and Davide will be holding the meeting tomorrow afternoon in Italian about the same topic as we heard today. This webinar record will be made available on the platform, on the danfoss.com platform, and as well as on the Mosra platform. So if you miss any information, just feel free to reach out to us. That's it for now. Thank you, and enjoy a great afternoon. Thank you, Eddie. Thank you very much.
Thank you, everyone.